Hi guys, I'm quite happy to connect back with you today. And just a recap, I remember in the course of this journey, learning data science, machine learning, AI with Dr. Onoja, we briefly looked at so many issues and we were able to build a foundation starting from the basics of statistics, descriptive statistics, and inferential statistical approaches. We also looked briefly why these methods fail and the rise of AI. I also briefly introduced you to the different kind of AI approaches we have, such as machine learning, and we zoomed into the different kind of machine learning, like the supervised and unsupervised machine learning approaches. Then I also drew your attention to how you could begin your journey into coding and programming using Jupyter Notebook and Python. I showed you how to do this installation, which you could watch in some of my previous videos that I have uploaded on my platform on YouTube and also briefly on Facebook. In the course of this journey as well, I showed you how you could be able to train your first machine learning algorithm on the Jupyter Notebook platform. Now, having trained your machine learning algorithm and you have saved the model, then what? A lot of machine learning approaches are stuck without going into production. About 70% studies have shown ended up on the desktop of the uh, developer without making it into production. This is quite a concern because a lot of people don't know how they could be able to deploy their model and bring it into life. So most of these models are just stuck and maybe get into publication, but without necessarily bringing it out to the end users that is being targeted. So today, I want to talk about model deployment and also briefly about app development. So when we talk about model deployment, it's just a process of integrating the trained machine learning model that you have already saved into production environments such as cloud like AWS and Google platforms. Why do you have to deploy these machine learning models that you have trained? This will be able to allow your stakeholders to reuse your model without having to go through the rigor or pain of understanding the codes you have written. Secondly, it's a move to help you to be able to experiment on how these decision processes have been taken and also to build a user-friendly tool such as dashboard and recommendation system and chatbot that your users could be able to connect and also solve their needs every time. Now, there are common deployment platforms that people use whenever they want to deploy their models from their computer. Some of these platforms ranges from web frameworks such as Flask and also Fast API. Then there is the popular Streamlit for rapid prototype and data app production. Then there is also the Docker container with a cloud platform like AWS or GCP or Azure. Then you can also be able to use the API, that's the application programming interface. Talking about the API, when you zoom at the API, it is an approach or a software that helps to connect your computers or with other computer programming platforms such as website or something where you could be able to fetch information from. This is actually a brief example of what the API means. Now, you need to serialize your model and also put it in a container whenever you're saving it, because when you are saving this model you need to make it to be machine friendly in order for you to be able to reuse it. So when deploying your machine learning models, you need to save them from the, for example, Jupyter Notebook platform, and then you could later on load them and then you could be able to reuse them when you deploy the app. So the uh, Python object is serialized into a binary format which has zeros and one, and then you could store them in a folder and or in a database or even in some sort of memory card or something. Now, you can be able to do that using different approaches such as the Pickle, the Joblib packages. There is also the hierarchical data format or HDF5, and also the container Docker that helps you to be able to do that. Now, if the machine learning is trained offline, the model is encapsulated and transferred to the hosting targeted deployment means. Then the computing architecture is set up that can be able to handle increased demands such as computing latency and all that using the cloud platforms like AWS or the EC2 too. Now, how can you be able to pickle these files? For you to be able to pickle your files, you need a standard Python package called Pickle. Now, that package module, what it does is that it serializes the Python train model into Python object. Now, when it serializes them, it dumps them into a particular directory or folder, and then later on you could be able to load them on, and then when you're transferring or deploying on the cloud platform, you could be able to effectively call this model and you could be able to use them. Now, here's a brief Python code or script on how you could be able to save this model. Now, the Pickle saved the model in sort of a NumPy array kind of form, and also the major problem is that when you are dealing with a very large model, it fails to be able to handle that. So it's only just small Python object that you could be able to save using the Pickle approach. So that's actually one of the limitations. Then that brought us to the Joblib Python package, also used for serialization. The Joblib Python package is built to efficiently handle the storage of large NumPy arrays. It's often faster and also smaller than the Pickle for sklearn models. Now, when you are saving a very large model, when the Pickle fails, then the sklearn in the sklearn models, then you could be able to use the Joblib package to do that. Now, in similar fashion of that you use the Pickle, you'll be able to import the Joblib, and then you could be able to dump the model, and then later on you could be able to load the model from the directory where you dumped it and called it. Now, the case become different when you are looking at uh, deep neural networks, such as convolutional neural networks or the image nets and all that. Now, in that kind of situation, you need to use a hierarchical data format or the HD5 approach in order for you to save the model and be able to call it back later on to use it. Now, this is because in the deep neural network phase, most of the time you have this data set coming in batches, sort of, and because of that, the whole thing is built in such a hierarchical format or a tree kind of representation that you could see. Because of that, it makes sense if you be, and also is very most of the things you do on using neural networks, they are more of the images or some sort of metadata. So that makes sense when you have them in more like a container where you could be able to release them in batches, sort of, in order for you to use it. Now, the simple code on how you could use it is you save the model using the H5 format, and then later on you could use keras.models load to call this model, and you save them with all the architecture, the weights, and everything that you have already trained. Now, that brings us to the containerization using Docker. Now, when deploying this model into production, we want the repeatable environment that's where the Docker can comes in. Now, the Docker helps to keep this model intact on all the files that you use during the training phase in order for you to be able to transfer it, so when you're using it in another system, it won't be broken. So you could be able to put all the codes, the dependency, and also the system libraries into the Docker files. And once you build the Docker image, you can be able to dump it in a container. And this helps you to be able to keep a consistency across the different kind of machine you use. So it doesn't matter what version or what kind of machine you're using, the Docker will be able to help to preserve that, and also easy for you when you're deploying this trained machine learning models in cloud such as AWS and Azure. It also helps to enhance collaboration, because when you send it to a colleague, they can be able to unwrap it easily without having any issue. And it could help to also keep the model more compact and also more portable and scalable for any other person to use. Now, this platform that I use so much called Streamlit. Streamlit, it helps especially if you are not really a heavy code developer. It really helps because it takes away a lot of lifting of the coding side for you. What it does is it's a Python framework that is designed to build this interactive data apps or data product. It has a minimal learning cost. It integrates with data science tasks such as pandas, sklearn, TensorFlow, and PyTorch. It's also great for demo apps, dashboard, and also model interface. When you host it, it's very easy to host it on Streamlit Cloud and also on Hugging Face Space and all that. A basic command is usually you import Streamlit as st, and then you could say write st.title, my first data app, and then welcome to my model deployment or something. And once you run it, you always see it displayed in our web interface. Now we also have you can be able to add different kinds of features to your app. You want it to, like for example, you want it to have multi columns, you want it to display everything at once for everybody to follow. So you can also make it to appear in pages. You can bold the image, you can include charts, sidebars, and so on and so forth, page structure, and all that. You could be able to do that Streamlit easily. However, it do make sense if you also learn some of the deploying options using GitHub. Now, the GitHub platform helps you to be able to host your code and also your packages and everything you use. And then from there, you could create a sort of a connection between the Streamlit cloud and also the GitHub. The two of them could be able to connect, so you could push from the GitHub and then you could be able to connect. If you don't have a GitHub, you could be able to briefly sign up, and then you could be able to start deploying quickly. Hi, I could talk about GitHub actually. It's a platform where you could host, like I said, your Git pages and all that, and you could be able to track changes in your code. You could collaborate with others. You could publish your project, and also you could deploy apps from platforms such as Streamlit. Uh, you could create that connection. Why should you use a GitHub as a data scientist? Well, it helps you to be able to track the different changes. So there's the version control. Each time you make a change, you could be able to see it. You could collaborate, you could share it with other team members where you could all could work on same code, override each other's work and all that. You could also be able to keep your work safe in the cloud. You could also show off your codes or something to others, and other people could also see your portfolio to see some of the things you have done. These days, people add their GitHub accounts to their resume, so you could be able to see what they have been doing, and also you could be able to connect your GitHub with different interface like Streamlit Cloud, where you could be able to deploy this together. So the basics of GitHub is usually you create a repository, which is you call repo. You can also commit, which is the version of your code. You can push or you upload or changes or something when you updated your script, And also you could be able to use branch by creating different branches where you could at the end of the day have like a master branch, and you can merge them as well. So the step by step is for you to go to the GitHub repo link and then sign up, and then you create a new repository, or you could clone that of others, and then you could start production immediately. First you could set up the GitHub locally, and then you could run the git command from your CMD or something, or the git CMD, and then you could make directories. You could also initiate to connect with the GitHub, and you could also push the files. What are the best practices for deployment? Well, for you to deploy, first you need the requirement.txt files, which usually it talks about the packages you've used and all the dependency during the model training or something. You need them, and then you need to handle all the exception or invalid input, and then avoid retraining the model in real time. Just load the pre-trained models that you have already used, because for example, if the model is very large, retraining the model could take forever, and if you are not using GPUs or something, that could create quite a challenge for you. Then keep the app modular and also readable. Makes it in such a way that anybody could be able to debug your code, and they could see what's happening, especially when you deploy this app in real time. Usually people would love to whenever there is an issue and probably you're not in that organization, another person comes, you could be able to use it. Also, make sure you secure sensitivity things like APIs. Make sure you don't share them with everyone, because that could be an issue for you. So these are sensitive information, so you have to keep them as secret. And deploy your apps or code or something, your scripts from the GitHub repository. You could connect with the Streamlit cloud, and you could be able to do the deployment and all that. It's actually the procedures and how to go about that. And interestingly, in the handout section, we are going to talk about the use cases of Streamlit in industry, how you could be able to use explainable AI approaches like Sharp and all that to build your apps. Also, they look at things like fraud detection and also health diagnostic apps, like for example, checking your weight, your BMI, your BP or something. Yeah. Then customer segmentation, visualization, and also real time social media sentiment tracking and all that. So